Hi everybody. Welcome to the December C++ Serbia meetup. As tradition states, it's going to be lightning talks. And to open up this year's lightning talks, we have Miloš, who is calling in from Prague, soon to be in Belgrade, right? But let's give it up for Miloš.
And okay, so what can we learn from Broforce? Now, before I begin with the actual presentation, I need to give the credits to the people who actually created these slides, because, well, I obviously did not create anything this good looking, and these are the people who created the pretty pictures, let's say. So first things first, what even is Broforce? So I don't know if any of you are familiar with it, but in reality, it's not Broforce. It's, in just a second. Right. Okay, it's Broforce. Yeah. Now you need to imagine some very cool guitar solo here, right? The game is about bow, 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 bow. It's like right? It's about yeah, right? Or just tactical swine, yeah, or simply flex, yes. Now, who are the characters of the game? It's Rambro, Brominator, Brodator, Brobocop, Brohard, Brunon the Barbarian, the Bro, because Bro is general neutral term, of course. Or Brophy, Brophy the vampire slayer. Now, modern gaming industry, I don't know how people with long hair live, but okay, whatever. So the modern gaming industry would like you to believe that gaming is about this like RPG, crafting, open world, survival, zombie, microtransactions, and I don't know, all the other nonsense, right? It's not about that, right? Broforce is a very simple game. So you go from left to right, you shoot things, you explode things, and you high five your bros. Now, high five is a very cool mechanic where if you are playing with someone else and you high five them, you slow down time, and it's just awesome, right? It's about just having fun. It's about getting together with a couple of your bros on a couch, in the same room, and having fun. Like even if one of the bros has an extra arm from somewhere. Now, C++, I don't know, like per program, something like that, figure it out. I don't know. Although, if you work in a big company with a big bureaucracy, you can just have a meeting. Well, this is quite tiny, but there are two meetings here that actually have a name. And one is on Wednesday from noon to 1, and it's called Broforce. And you can create a meeting, get together with a couple of bros, and just play a game, have fun, right? The other meeting is Let's Talk C++, and again, you can just create a meeting, get together with people and talk about C++ or whatever you want. Managers usually respect the meeting, so if they see the meeting, they're like, it's busy, we don't touch them. Or, Brunestro Pro, Herb Brotter, Brotmeyers. Okay, I know they don't look anything, but the AI has no idea who these people are, so just like roll with it, okay? I just need you to be hyped. Right. Klaus Iglbrugger, Ivica Brugosavljević, Bro Ivan Brokić, and Bronan Aranđelović. Or, yeah, you can just like come up with other names for other people. I hope this mullet looks as good as I imagine. On like a more serious note, maybe one thing I realized while preparing this is that maybe others similar like me got into programming because it's fun, right? You were solving some problem and we're like, oh, this is cool, this is fun. I enjoy this. I would, actually like to do this. And not, oh, I'm gonna like close so many Jiras and open so many tasks and like there are gonna be so many meetings and we're gonna circle back and like no. It was just about programming. Occasionally, even if you're doing a group project and you have people who actually work on group projects, you get together with a couple of their bros and do some programming. So one thing I intend of trying, and maybe you can do, is when you run into interesting issue at work, you agree with your team that you're going to be offline like a day or two or something like that, where you don't go to Slack, Teams, whatever you use. Skype, no meetings, no emails, nothing. It's just you, code, maybe a couple of your bros, if you have them. If you don't, then like do it on your own. And well, just do programming, have fun. Again, not really relevant. The real point here is this sentence from the last year's talk from a Christmas movie. Hallmark Down to Christmas is still happening. You should still watch them. They're still awesome. And yeah, like every once in a while, just let the world be a magical place. Now, again, the season of giving, and well, there is this like children's shelter. You can donate, you can do something good. Basically, there is a bunch of little bros that could use some help and you could help them. I was also thinking of like organizing maybe some like, how do you call them, like toy drives or something like that, where we would come together and like collect presents and stuff like that. But I have no idea how many people are interested and I have no idea how to organize that so quickly. But if you are interested, like send a message on Discord or something like that. Like, let's make it happen. And yeah, with that, I'm done. I will need to go now because I am flying tomorrow and I have stuff to finish up. Enjoy the rest of the evening.
Thank you.
Yeah.
Thank you, Miloš. Look forward to having you here in Belgrade. So, after Miloš, who was online, we're now going to have Aleksandr.
One, two, three. Okay, is it okay? Ciao svima. Hello, everyone. My name is Aleksandr. Like some of you may like heard of me from Slack and Discord, like C++ as Tony. So today I want to tell you about one little like very small trick which simplifies like how you write CPOs in like modern C++ and stuff like that. It's based on very known technique like tag dispatch, but like it's a very specific example like how we actually you would use it in like in real code. And CPOs stand like for customization point objects. I hope like most of you already know about it. They're very neat, right? They provide us a unified interface for some functionality, and they can adapt like many customization strategies we have. But very often, like they have this issue that it's kind of hard to write because like a lot of overloads. We use like trick like tag invoke, like ODL dispatch and stuff like that. And especially debugging is very awful when you like make a mistake somewhere, or it's like another overload which you didn't want to pick, like was picked and stuff like that. And one of the benefits which I learned recently about this stuff is saves a lot of compilation time, like 5 minutes on a 12 million lines of code basis, because like template specialization kind of heavy on compilation time, but CPOs, they like reduce number of that. And this trick I picked from my friends which used to work at Netlify, and there's a link to that. And they have a very high quality like C++ like core library. So check this out. A very simple CPO may look like this. Like for comedic effect, I like properly made this function like this 4 times, but like in real code, you won't really need to do all of that. Like for finite awareness, like usually just one of the stuff in declaration is enough. And most of this you can replace with auto. And this is just a function object. It overloads the call operator, and it provides a default implementation. It's just a simple function which will return like default string. And on the right side, we will have like 2 types, and one of them will provide their own customization, which will be picked up by ADL, right? It will return a custom string, and we will try to print it with our very new like print include. It will print like default or custom depending on which type have which specialization. Or if it doesn't, it will pick up the default one. But for the sake of the example, we will make like a bit more complex customization point called inter. It's a customization point just for assignment of an object into another, right? But with very, very specific behavior, which we want here. Like if it has a member function, we will want to always prefer that. If it has a free function, then we will prefer that, but only if there is no member function. And if nothing else is found, we will just directly try to assign the object, if it's possible. If it's not, then we will make a compilation error. And here specifically, we will not talk about like tag invoke and stuff like that, because it's not really nice in compilation time as well. And to satisfy our requirements, we will use these concepts, like simple enough, right? We just try to call into what we want to call. And here's a very, very naive way to implement this CPO, right? So we'll have 3 overloads for each specific one. It will kind of work, but like until it doesn't. If we, for example, we have a type which tries to have many overloads like customizations, it will throw like, it will be an ambitious call, right? Because it can't figure out which overload to pick. But, and type could just be as simple as this, right? It's like very easy to get such behavior. So we know how to solve it, right? We will try to exclude overloads which will not need in the order we want the priority to be, right? So we'll have like, on the first, the most important priority, we'll have only 1 requirement, and on the others, we will try to exclude all previous requirements in the order we need these priorities to be. And but it's like not very nice. We don't really, especially like on 3 overloads, it's okay. But if you have like a lot, then it's kind of a problem. And if the requirements are also not as simple, maybe you have like not just simple interface, but like, for example, in this assignment CPO, we would like to have a version, right? And it will be very difficult. And to solve this, there is a very simple solution via tag dispatch. It's a special structure called preference. And preference, it's derived from its own instantiation from the less number. So the most derived preference will have the highest number. And this preference will have the highest priority in our overload set. And we have a helper variable, template variable called prefer. And we will rewrite our CPO like this, just using like tag dispatch on this preference. And we will put this parameter in the order we want this function to be picked. Why does it work? Because the most derived preference will be the better fit. So it will always try to pick like the most highest number. It will try to check the requirement on the concept. If it doesn't work, it will go to the next fit. So we don't need to exclude all the previous requirements. It's very like straightforward and simple. And obviously, just one little problem is that we always need to manually check that when we call the stack dispatch, we pick the highest number which we need. But that's it. And here is a Godbolt link if you want to play around it, and the link to the source code from which it was taken. Like, there you go. Thank you. That's all.
Thank you, Alexander. We're going to take a little break. So everybody who came in just now, feel free to help yourself. Cookies or water or soda. And next is Ivan. Oh.
So, hello, I'm Ivan, and I'm a game developer. And I'm going to talk about how making a custom game engine in C++ is not that hard, actually. But okay, well, let's see. Okay, so yes, my background, I actually studied architecture. It had nothing to do with programming. But during the studying, we learned 3D modeling, and then I started modding games because I always played games, and but I never knew that somebody can make games like in Serbia when I was in school. So yeah, and then I heard about Unity, and for now 10 years I'm making like Unity games, and I did many game jams. You can see some of these games. You can see all of these on itch.io, nothke, with my name, and yeah, and at some point. I started making this procedurally generated rally racing game. It was called Infinland, which I actually never finished, but in it, the most important thing was that I wanted to procedurally generate the world as you go, like as you're driving, the new terrain is being generated and stuff. And I did all this with like you know, just 3D generating vertices, putting UV textures and stuff like that. But it turned out that it was way too slow because, yeah, for example, here is one generation, like how I did it with like some Voronoi, and each of these like nodes were like intersections, and then edges were roads. But it was way too slow because you have to generate colliders as well, and that was the limitation of Unity. So a friend of mine said, why don't you write your own engine in C++? And I have to thank him because Shah is a good friend of mine, and he's a super cool guy. You should check his blog out and the stuff he does. And I was, of course, my first thought was like, are you crazy? Because I don't want to make engines, I want to make games. And well, then COVID started. It was 2020, and he sent me some tutorials. This is from the journal about OpenGL, and basically it was kind of like an introduction into C++ as well. And yeah, and then 2 weeks. Oh yeah. Oh wait. Oh wait, something is missing, I think. No, maybe not. Yeah, but yeah, I had so because I came from C#, right? It was, and then I go into C++, and I'm like, okay, there's so many weird things in C++ going on that I don't like. Everything is just, I have no idea what's going on. Like this, okay, you have a for loop, right? And I want to print something 1, something 0, something 1, something 2, right? And does anybody know what's happening here? Tell me, what's the output going to be? No, it's not an error. It actually compiles and it shows. No, it will not show a number. Come on. You got it right. So you get this. And you're like, what the hell is going on here, right? Because in C++, in C#, you do this and you have string concatenation, right? But here, of course, this string is not a string, it's a char star, it's a pointer. So you're like, actually, with a plus number, you're offsetting this pointer, right? And you're like, oh, and you get this, and it's like, what the hell? And this was happening all the time in the beginning until you figure out, like, oh yeah, okay, that's just how C++ works because it's built on C and everything. And yeah, anyway. And then, of course, you're met with this beautiful Visual Studio interfaces, which is like, because, yeah, I use Visual Studio anyway. But it's like, it looks like it's from 95, and you have this one line where you have to write Oreo includes, and it's like, what the hell is this? And then you have to build all your libraries. If you want to build a library, I had to write this for myself. Like, okay, this is for bullet physics. Okay, you have to clone your, you have CMake. I use the CMake GUI because I don't understand how CMake works, you know, and everything. And then you're like, you have to put some special stuff in there. Anyway, it was way too complicated. And then you, in the end, you include it. But 2 weeks later, I actually made the game. And this was my first game in this engine, although the engine didn't really exist. This is like a small horror game. It was just a character walking around because that's what I managed to do. But I had these shaders like PS1 style because I knew how to do shaders from before. So that part was super simple. But yeah, the setup and everything was awful. Okay, so. And then 4 years later, this is where I'm at now. Shakedown Rally is like, yeah. So this is how it looks like. It's also like retro-styled pixel art, but it's a rally game that you can play. I can even show. So it looks like, for example, and oh, nice. Yeah, maybe it's too loud. Okay, let's see. Yeah, you can drive a car around. Oh, my keyboard is not very. Oh, wait. Yeah, my keyboard is not very good. It's very broken, but yeah, you can go on itch and you can even play this demo. Anyway, that's it. Okay, so that's how it looks like. Just. Okay, and yeah, it loads in less than like 2 seconds. So you can get, so that's the coolest thing. Anyway, yeah, what this build with the MSVC in Visual Studio, I'm using like the latest C++ because I can, I can just update. I'm using now Premake for configuring the project. I'm not using this Visual Studio interface anymore. But yeah, that's the best solution I found because Premake can build a VS solution for you, and you have this nice Lua text file where you can just put your includes and libraries and everything. And yeah, the engine itself is now included as a static library in the game, but I have them together in the same solution so I can build between. And I have about 5 to 10 second compile time if you only touch the game, if I only change the game. So that was the thing that I really wanted to get down as possible. So I forward declare a lot of things. I use pre-compiled headers and yeah, stuff like that. Anyway, yeah, a lot of libraries that I use. Yeah, it's OpenGL, so GLFW, GLM, Glue, TinyGLTF. I load all the models with GLTF. Initially, I made my own format, but then I realized that GLTF exists and it's like a scene file. Yeah, one thing is that I don't have an editor, so I just load the entire level as like as a GLTF file. So it's basically like if you had like a scene in Unity, it will take care of all the meshes that are instanced and stuff like that. So reuse them. Anyway, and yeah, other stuff, SPD log for logging. It's pretty cool. When your game crashes, it will dump everything into a file. Bullet for physics, I said, they're in GUI. For GUI, and all the 2D graphics that you saw, it's like in GUI, actually. I'm not rendering it myself. I just make a transparent window and draw all the 2D stuff. Tracy for profiling. Yeah, Solid for sound, blah, blah, blah. Okay. Yeah, how do I write my C++ code? It's not clean code at all. Actually, this is my main, which has 5,000 lines, because why not? And everything is here. I can just, if this is my hashtag GUI, for example, and I'm in the GUI part, and I just put all the GUI stuff in there. Yeah, and yeah, why use files? Okay, I do have some things in files, okay, but yeah, I use a lot of lambdas as well, because lambdas I can write right next to. And yeah, for example, this random rotation, it's just there, like I'm using it here. This is particle simulation. Yeah, it just, anyway. Huh? Oh, that's just the region that you can collapse. It's a feature. I don't know. I don't know. Is it? I think it works in every editor. Yeah, I mean, the compiler will ignore it, of course, but I think that every editor implements it. So anyway, yeah. Anyway, yes. I also do all my input handling in the loop. Yeah, and this is of course start of the loop. And everything is on the stack basically. And everything that's on the heap is in the vector. So like basically, yeah. Anyway, one problem that I have in the engine is that I can't remove objects, but that's fine. I don't need removing objects at all. Because of course, if I remove an object, it will destroy all the pointers. But who cares? I don't need that. That's the best thing about making a engine. Okay. Anyway, yes. Yeah, most things are in like a fixed capacity vector so that it doesn't reallocate. This is one of the most fun things that I discovered early on. Yeah, I use stdspan, which is a relatively new feature wherever I can to pass parts of arrays and vectors or normal C arrays into all the functions. Yeah, std string and string view, but most of the other std library I use a file system, which is pretty cool. It's also recent, but yeah, rarely any other stuff from the standard library. I don't use any inheritance. If I need it, I just have tagged unions. I just put a little union with the type in it. Yeah, I'm not using smart pointers because I never free things. Of course, like a vector is basically a smart pointer, but yeah, like most of the things in the engine, it just when I stop the game, it just OS takes care of it. I don't care. Yeah, and this is like one of the when I started C++, it was like my friend was suggesting me to do like modern C++, and it was like std optional, std reference wrapper, and I'm like, what the hell is going on? It's terrible. And so like if I need an optional, I just do a pointer with which is initialized to, because why would you need this? And then I need to include some template libraries which take forever to compile. Anyway, so. Yeah, or if I want to, I have this like I return a default object. Like if you try to find the game object by name, I just return some dummy object. You can just operate on it, and no errors, nothing. But at least nothing happens. Like you don't crash. Yeah, and I use templates, but just for generics, like very light stuff, like containers and yeah. Anyway, I don't try to abuse them, like the previous speaker. Or most of the actually C++ meetups was like about basically abusing templates, I think, like talks. Okay, anyway. I don't know. I mean, I guess you knew about this before, but I don't know. Yeah. Yeah, I think there's a lot of like masturbation in like I wanna make this cool system which is think about correctness of the program and like invariants, you know, and stuff. And like in the reality, who cares? It's just pointers and it's just data at the end. Anyway, so yeah, I hate functional programming. No, I'm joking. No, functional programming is cool, but I feel like C++ kind of functional programming is missing a point. But anyway, okay. Yeah, why I love C++. If you struggle to like learn C++, it's you learn a lot about how things work. It's very versatile. It's like from low to high level, you can edit memory, and yeah, it's super cool. But you also have a lot of benefits of high level magic. I love lambdas. I overuse lambdas because they're the only really good feature, I think, which is like high level. Okay. Yeah, there's a ton of resources, huge community, many libraries. And yeah, C++ is here to stay for the next 50 years probably or more. So just learn it and you will have a job. And every year there's more and more tools and it's always evolving, like it's changing. It's becoming much more functional. And I mean, you have much more things in it and stuff. Why I hate header files. I absolutely hate header files. Because it's like 5 languages in one. You have the code, you have templates, you have the build system, whatever you use, macros. If you do any testing, I don't do any testing, but and now reflection is like, why is it a new language? I don't know. Yeah, compilation speed could be better. Yeah, there are modules, but they're not there. I tried for 3 years. I tried building modules. It always fails. Except this summer. Like this summer, I managed to build my first STD library with modules, and it's like, whoa. But then how do you get other libraries to work with? I don't know. Anyway, yeah, and when I code C++, I think a lot about architecting the code, as I call it, like, oh, where do I put functions? Where do I accept I have this one main function. But yeah, the engine is like, it has multiple files. This is the 5,000 line thing I was showing. That's just the game. That's just the rally game. Okay. Yeah. And if you want to make your own engine, I suggest instead of taking OpenGL, you should start with Raylib because it is C, but it's very simple to include in news. You can just start like create a window and you get the window and you're like, give me load the texture. You load the texture, put it on the sprite, you have it. And it has great cross-platform support. And you can build it for web as well. And yeah, it's a great community and it's like rising in popularity. And yeah, SDL3 just came out a few weeks ago, but SDL2 was, yeah, I don't know, it's used by Valve. So that's like, people will always quote that. I also use Sokol. I tried it. I never made anything with it, but it's like it's much more struct based. You fill these structs with like, it will do a lot of GPU magic in the background. And yeah, but it's pretty cool. And it's also cross-platform and you can do any backends with it, DirectX, OpenGL, web and stuff. Anyway, yes. But there's a, yeah, I can't, I can't finish the talk without mentioning something that I got really interested in the meantime while making the engine, and that's Zig. Because it's like just, I'm hijacking C++ meetup, yes. Because it's like, it's just the right thing that I need for my use case. Because it's like C, but it's better C, and it's not object-oriented like C++. So I don't know, it's super nice. And you get a lot of features, and it's super fast compile times. And yeah, and build the system is super nice and friendly. And yeah. Yeah, anyway, all the things I wanted from C++, I got in Zig. But as I said, C++ is here to stay, so you're safe. And yeah, I want to end with the title, making a custom engine is not that hard, but there's actually too many things to do. That's the only issue. It's like, you know, you have to include all the things. You have a physics engine, GUI, whatever, and it's like, yeah, there's just, it's not that hard, but you go step by step and you realize you spent years making it. So that's the only issue. yeah, there you go. And that's about it. Yeah, thank you. Go. Also, I just have to mention, I'm also part of the Centrala, who are super cool. They're in the back, they're there, which is a super cool community promoting open source and free education and stuff. And you should check out the events because there's there's no internet. Anyway, but yeah, this is Shakedown Rally, and you can also buy it right now. It's like alpha, but yeah, there you go. That's it. Thank you.
Thank you, Ivan. Thank you. Like I knew a saying that was like, you are either building an engine or making a game, and I'm glad to see that it's possible to do both.
Yeah, if you choose to make a small game, like don't make GTA 7, you know, that's, I think so.
Thanks, Ivan. And next we have Sergei, who is gonna talk about. Talk about what?
Plljekas. Yeah, 1, 2, 3, 4. Perfect. Perfect. All right. Yeah. Hi, my name is Sergei. Some of you already know me. And yeah, I'm language enthusiast, so I fiddle with other languages. So this talk will be not about C++, but here's secretly people from at least GS community. I will not tell who exactly. So just know, to let you know, there are some imposters around you. So, so it will be not around, about GS2, and it will be not about Python. So, all right. First of all, like, have you heard about MXN problem or NXM problem? It's a problem when you have concurrency and also you have parallelism, which are, as you know, different things. Imagine you have a problem, you have like plljekas studio, and you have only 2 pans. And you have an order which, in which you need to prepare three plljekas. And as you know, plljekas should be fried from both sides. Each side, say, 5 minutes. So what do you do? Like, probably the easiest approach is, well, you fry, oh no, I messed up. It's like, it's supposed to be, oh, let's fix it online. That's good. So we first fry first and second plljekas up. Then we fry like first plljekas down, right? Second plljekas down. And here we have last plljekas, which we can't tear it apart and fry. So we have to use only one plljekas core. Yeah, AI is sometimes smart, sometimes it's not. So how many minutes do you need to fry it? Oh, by the way, I probably, yeah, actually had the solution. So as you can see, you need 20 minutes to fry it, right? But what if you can do it faster? Any suggestions? No, you can't cut plljekas. It's in this country is prohibited. You'll be expelled. Yeah, exactly. You need concurrency. You need concurrency. And here's a concurrent solution. Let's see if I have an error here. As you can see, every time we have different plljekas on different plates, and we need only 15 minutes to prepare a plljeka. So yes, exactly. So this is another. Yes, exactly. According to plljeka church, it's not allowed. No, we don't need traditional plate. We only have two cores, core duo, dos. Yeah, we need next generation of plljeka processor. So, yeah, of course. In plljeka business, we always play with fire, you know. So, the thing we just discussed, it's called latency. So as you can see, in first example, in 10 minutes, you will have 2 plljeka prepared. So latency for first and second plljeka is 2 minutes. For third plljeka, you have 20 minutes like latency time. And here, as you can see, for first plljeka, you have how many? 10 minutes latency, but for second and third, you have 15 minutes latency time. So this problem, what I want to showcase, this problem is not easy, however you cook it. So one of the first languages which addressed this very seriously was Erlang. There was many attempts, obviously, but like the most famous and like which was a turning point was Erlang, because people who created Erlang in Ericsson Labs were doing some ATM business, and for them it was very important to make super durable and hugely parallel and concurrent systems. So let's add up another problem, which is Fibonacci numbers, and let's solve it with Erlang. So what do we have here? Like usually we have 2 types of tasks. Some of them are highly concurrent, but we try to make them CPU not intensive. And we have highly CPU intensive tasks, but they're usually just mathematical, let's say, pure functions. Like, for example, Fibonacci, if you have number of Fibonacci, it's kind of enclosed task. You can calculate it in one core, however you like. But you also can parallel this task. So what happens here? So here you have pattern matching, which says if number lower than 20, we calculate it just recursively. It's terrible solution, obviously, but it will fry our CPU well enough. So let's try to run it. Oh, by the way, the source code you can grab here. You can open it on your phone if you want to like follow in the code. I will give you a few seconds if it's even scannable. Hopefully it is. So we go to Erlang. Oh no, it's strange. It's yeah. So what do? We start Erlang. We load our Fibonacci function, and let's say we need to calculate it from small number. Yeah. We can load it a little bit more. As you can see, all cores are trying to fry my notebook. Yeah, so for Erlang, I will not go for big numbers. Erlang was built mostly on, don't want to say, it was built over a Beam virtual machine. And on this virtual machine, since it was so cool and influenced a lot of people, there is around 30 plus languages written on Beam virtual machine. One of them is Elixir, which looks like Ruby, but secretly it's kind of Erlang. So the same solution looks like this, probably less elegant than in Erlang, maybe more elegant, who knows, like it's Ruby stuff. Yeah, as you can see, there is no syntax highlighting. It's intentional because it's not like not the point. You need to kind of check it is like foreign language. For some of you, maybe it's not foreign, but well. So what happens here? Here you have a function which is CPU intensive, and everything else. Oh no, actually I'm wrong. This part is CPU intensive. Again, pattern matching, recursive solution. And here we already use things like channels. So we spawn our subroutine, we have our parent, and we can send something to the parent when the job is done. So pretty simple stuff. And let's run it. Let's see how it fries cores. Yes, Elixir. Now we calculate number 52 of Fibonacci. It will take some time. And yeah, as you can see, it utilizes all cores as it can. And also, I'm in like some power save mode, so it will take a while. So the idea is actually, it's not really hard to write MXN problem in languages which already have frameworks to do that. So you can just, of course, you need to do your system design properly. You can separate your CPU intensive tasks, and you can schedule it through different like type of mutexes among your cores. There is pretty much two types of mutexes. It's channels and everything else. That's why, yeah, it took like around 1 minute. So Erlang was one of the first channel-based architectures. The idea is like if you have very, very small channel, it's in a sense a mutex. Because you can kind of step on your foot when you add something. You need to lock this part of the memory where you want to read new values. So it's kind of mutex, but it's only become in this sense like philosophically mutex just because you have very edge case. But usually you have a buffer. And the queue works very well because you write and read from different sides and you don't really trigger those locks. That's why usually channels are faster even than atomics in certain scenarios. Like I'm not even talking about locks, it's usually terrible. There is another language on Erlang ecosystem which I want to mention until I go to another languages which you can see. It's Gleam. It's a new kid in the block. And the idea of Gleam, it's a completely new language, which influenced by obviously some other languages. One of them is Rust, for example. The idea is like it's a fully functional language. It can be compiled to either JavaScript runtime or to Erlang runtime. Also, it doesn't have if statements. It has only cases. Why is that? Because when you do pattern matching, you can be sure that your solution is exhaustive in terms of cases. So for example, if we did an if statement, we could say, okay, if it's 0, answer is 0. If it's not 0, answer is 1. And we did a silly mistake. And we actually didn't cover all cases in terms of our logic. But here you can see, okay, if it's 0, it's 0. If it's 1, it's 1. If it's some arbitrary number, we can make a recursion. Obviously, we didn't cover negative numbers. We can also do that. In this case, it would be some strange result, but we will not touch it. So again, it looks more like normal programming language. You see, you have a function, so-called pattern matching. Yes. Yeah, but it's different. It's if inside the pattern matching. That's good. That's good. So it's probably not really easy to see, but here you have so-called joker underscore. So you actually match everything if certain scenario happens. Yeah. So also, as you can see, it's pretty simple code. Can you guess how many lines it would take in C++ to make something like that? Well, I don't want to. Yeah, of course, but how many syllables you need to type? Oh, in the times of AI, probably not a lot. So let's run it. Glenn was also influenced by new modern tools to build things. So you don't need to fiddle with CMake or any other stuff. You just do glim run and everything works, hopefully. Well, because it's already implemented. Why should we implement? No, actually, I'm not defending functional languages. Everything is good for its job. So it's mostly languages for, let's say, web. Yeah. It's recursive, so it's not tail recursion. It's like disallowed to guess anything.
But do the functional language really rely on figuring out the recursion is actually just a problem?
No, it's not that smart. Like when you have tail recursion, you should be specifically calling only one recursion at the end of your, like, how to say, tree of logic. But if you have something like, in this case, Fibonacci n-1 plus Fibonacci n-2, you have two recursion calls in one statement, so it's impossible to easy guess. You need to have a whole mathematics of productive functions to like calculate the real formula and calculate it. So like for compiler, too much of the work. But there is one thing which is called, you probably heard about LLM-based optimizations. So before it was profile-guided optimization, PGO. And now it's LLM-guided optimization, LLGO. It's part of the LLVM. It's now in deep experimental, but it already gives you a lot of fancy optimizations, which are, it looks for a pattern in code and compiles it to something which is which produces the same result, but say faster. So for example, if it recognizes that your for loop actually calculated something like n squared, it will just make one assembly line and that's it. It's for LLVM. So basically what has target as LLVM, C++, Rust, whatever, like you can have those optimizations for free. All right, let's go with other languages which are not functional. Let's start with Go. So Go was influenced by also channel-based concurrency model. So as you know, probably in Go, we have everything through channels or atomics. And the statement of Go, if I remember correctly, is you use atomics and locks only for something which is stateful or cache. It's pretty much also stateful. Everything else should be done through channels. And what you can see here, it's called asymmetric recursion. When you do, in Go language, if you're not familiar, when you say Go and some function call, it will spawn a Go routine. You don't have full control to threads, but you can assume that this work can be done in another thread or not. And it's for scheduler to know who will do the job. The idea here, we spawn one hand of the recursion in another routine. And another hand of the recursion we do here in our control flow. And when we finish with our work, we assume potentially other work is maybe done, maybe not. And we wait for the rest of the job. So it's pretty good style of prioritization. You don't do a lot of overhead with sending tasks here and there. So what it does, so basically it spawns, say, left hand, calculates Fibonacci here, and then it waits for result from channel to get the result from spawn task, and just do the rest of the job as normal. Again, here you can do, instead of switch case, just normal if statement. It's just a matter of preference. It doesn't matter. So basically, as you can see, Go try to mimic that good old style channel programming. All right, can build. We can time Go around. Go. Let's go. Again, as you can see, it's easy to burn your cores however you like. It's supposed to be a little bit faster than Gleam. As you can see, Gleam took 39 seconds to calculate this. Go is supposed to be a bit faster, and yes, 17 seconds, pretty good. As you can see, CPU time is 1000+%, which makes sense. It's in when 100 is 1 core. And let's see how Rust's, oh yeah, honorable mention to never released language V, which I actually admired at first and still kind of have some hopes on this language. It's kind of homework over Go and Rust, because Rust is probably too hard and impractical for certain tasks where Go shines. But the problem of Go has nils and other problems, but mostly nil statements ruin everything for Go. V has a little bit more robust syntax, but assumes that if you know Go, you know like 90% of V. But also it doesn't have nil statements. It has a little bit better type names, like you can specify like U64, which is more convenient than to say just int or long or whatever. Also, it has kind of the same idea as Go in terms of you just say Go Fibonacci and it will spawn coroutine. But you also can say instead of Go spawn, and it will specify that you will spawn a thread. The only problem of V that Go command for now fallbacks to threads. It doesn't spawn like lightweight threads, unfortunately, and this is haven't been done for last 4 years as much as I follow this language. This is unfortunate. I will not run this code, but Another honorable mention of a language V, a lot of people say that, oh, it's Go doesn't implement certain things like generics or templates or something. By the way, they added generics in the end. Because it's hard to compile, it's very slow. V language has all of that constructions, and it compiles like 500,000 lines of code under 1 second on like reasonable laptop. So probably the problem was not in parsing and compiling the code. And the last but not least, we can consider Rust. I know you guys all hate Rust, but well. So I have multiple implementations here with channels and without channels. It doesn't really matter. They have different, obviously, timings. It was just for experimental purpose, and you can check it afterwards. I will just focus on the simplest implementation. Again, it's could be done just in threads, but since we consider like M, X, and problem, we make it a little bit more complicated. But again, you just spawn another routine here, which yeah. Yeah, of course. Well, in Go and in Erlang-based languages, you can also use a library, which is a standard library. So we can obviously write everything in assembly and be pure as pure. Yeah, standard Rust is very small, and the idea is like it's one of those languages where batteries are not included. So if you really need something, you need to add it. So for example, here I use Tokyo, which is kind of de facto standard runtime for asynchronous calculations in Rust. Actually, Rust before 2015 had very similar to Go nature. It had internal asynchronous runtime, everything, and then it decided to go in another direction to be very small in terms of if you don't need something, you don't include it. I don't know, actually on the fence about this decision, but well, it is what it is. So here, as you can see, it's also a symmetric prioritization where you delegate some work to another routine, do it yourself, and in the end, you just combine the two results. The unwrap here, as you can see, it's another feature that actually sometimes like a lot of things can go wrong. And when you write code, you might not think about every single case, which will lead to panic of your program. In Rust, you have to handle all, like literally all the cases. And if you don't really want to deal with them, you can say, okay, if something went wrong in this specific case, I know it can go wrong, but I don't care. So you say unwrap. And if this is not optimistic scenario, for some reason, this coroutine crashed, you just panic the whole application, and it's like, it is what it is. For example, in Go, you might have a stale state. If something panics, it will not turn off the whole application, and it will be in some kind of zombie state or inconsistent or God knows what. All right, let's run it. In this case, we are testing just simple implementation. And in Rust, you use cargo run. And -r means release version. By the way, as you can see, I include It's not really compile time, but we can do even with compile time. We can do cargo clean and calculate it with full compilation cycle. So let's see if we can beat Go. Probably not, we already spent too much time. Just compilation took 9 seconds. No, the whole idea of this project which I made, why did I do so many implementations? The idea was it's kind of general case of M on N problem, which you will implement without using too much like tricks. It's how it's supposed to be done in the most simple way when you face the real problem. Obviously, if you calculate Fibonacci numbers, you just use mathematics. But the whole idea of this experiment was how easy to write code which handles concurrent and parallel environment, and also how it's supposed to be done in the most simple way in this language. So for example, as you can see in Erlang, it's, in my opinion, the most elegant way possible, and it also can be digested by lines. So this code, literally, in my opinion, is basically English. If you know pattern matching for functional programming, that's it, because everything else, you have a parent, you spawn something, and you just get the result in value X, and you receive results from Y from channel, and you get the results. So it's as easy as it could be. But when you start to do it in other languages, you have more complications. Like here you have model, which might be good, might be bad. Let's go to Gleam. You also need some libraries, obviously, like everywhere. But in my opinion, Gleam is kind of reasonably readable. So if you're from pretty much any language, you can come to Gleam and everything looks normal, especially if you're used to types. If you come from, say, Python or JavaScript, it's maybe not that convenient. But again, in Gleam philosophy, you specify types only on input and output, assuming that everything else can be like inferred from those types. And like, in my opinion, in 99% of the time, you can do that. Because if you know what came, what's supposed to go out, you always can digest it. If you do it for every function in the system, obviously. In Go, it's already hit or miss, in my opinion, because first of all, the language is very opinionated in terms of simplicity, which sometimes is good. You can also go through Go code from any background and understand at least what's going on. But when it comes with channels and tricks, might be confusing. And Rust is just like, yeah. But it's the fastest when it comes to runtime. So well, I'm on those. So yeah, that's it.
Even though it's a C++ meetup, you got to see other languages as well.
So in this mix-up, who went to other languages meetup? They are listening about C.
It's like we went up to those languages and we see it go down.
Okay. From the last update in Windows, it started changing my. It changes like twice a day. I don't know how to stop it. I haven't got around to it. So this is from Paris. Hello, everyone. I'm Misha. I'm a professor. Therefore, this lightning talk will be like an exam. So maybe word exam is too strong, more like light-hearted quiz, which aims to check your knowledge of C++ syntax, but in a roundabout way, in a flipped way. So direct way would be I would show you some piece of syntax or a piece of code, and then you have to know what it does. Here we will focus on a point. So point is or a dot is a punctuation mark used a lot, and especially used in C++ for many cases, for many different syntaxes. So we will start, so point as in 4.2, we will start with the first group of questions, and it's related to just one point, one dot. So idea is to remember all the different cases where one dot is used in C++ syntax. So for this first category, I numbered 3 to 4, depending on how you group them, right? So you start. Give me one usage of dot in C++. 4 floating point numbers, of course. So 4.2, etc., etc. In some slides, I will add some interesting fact about that particular piece of syntax. So what I find interesting here is that you can use and have to use P in the new version of C++. You look it up. Why? Instead of E as exponent, there is a case where you need to use letter P for exponent. when you use hexadecimal numbers for expressing, yeah. But as I told you, very interesting thing. Okay. Other cases? Of course, that was easy. So accessing members of object, I highlighted 2 slightly different cases. So the usual pattern is variable name dot member name, but it can also be dot template as a keyword. But there is also another special case here, which I can kind of count separately, and it's pointer to member of objects. So it is slightly different, this point star. Okay? But we have one more. No namespace. It's more than one. Sorry? Include no. It's a bit newer thing from modules. It's a bit of cheating, okay? I understand. But these points here do not have intrinsic meaning. They are used informally, okay? But still, I maybe missed something, of course. Sorry? Is the name of include? Yeah, okay. That can be, yeah, that can be related. Although this is explicitly mentioned in the standard as a piece of syntax, whereas in this case with include, it's like just the name of the, but you're essentially right. So, okay, that's for the first category. We have only 3 cases for just 1 point. But for 2 points or column, we have much more cases. This is the so let's start. Labels. Sorry. Labels. Here they are. So we have cases inside switch. They are essentially labels. But here also I have a subcategory because go-to labels are slightly different, but they are labels nevertheless. Input, output. For the namespace. I have 4 dots category, so remember that one. Double call, yeah. For each, okay, range 4. Here it is. That one was easy. Yeah, of course, ternary operator. Here it is. Yeah, I probably missed that one. How do you... I don't know that one.
When you want to do like float decimals, how to pick how many decimals, right? Isn't that like
in printf formatting string. Okay, but that is not part of a syntax. It's more of the how the printf works, right? Member initializer list, of course. So quick sub question here, which will be the order of initialization here? Yeah. Okay, important sometimes. More? Yes, that's another one, inheritance. So here we can also have public, protected, private, and also member access specifiers. Again, same thing. So, but we are missing a few more. Come on. There are a few very obvious ones that you're missing. Very good. In more. Try it. We have 2 more categories. Yeah, you should try that one. So you see, this is how it's used in modules, but few more. You remember something new with enums? Okay, for enum underlying type. It's not technically, right? But we have few more. One is very, very obvious. It has always have to do something with low-level programming. When looking at just bit fields. Of course, bit fields. Also, a few new things related to bit fields from C++20. So you can initialize it. Sorry, this?
what it does,
yes. Yes, it initializes the bit field to 6. Yeah. Yeah, okay. Now, we have 2 remaining, which are not quite obvious. One is kind of a cheat, you will see. The one which is not a cheat is in attribute specifier, but I think someone said that. Someone said that? No? So you can use this thing since 2017 to group this prefix for all the attributes. So instead of writing it like this, you can write it like this. Yes. Only standard C++. Yeah. Yes. Yeah, you can do this since 11, but this only since 17. But this is answer for the fourth category, so you should remember this one. And finally, a cheat, which is not exactly a standard, but used a lot, again, in low level, and that's assembly statement. And this is the most often used syntax for that, GCC syntax, where you have these columns which have exactly. So this concludes the biggest category. The next category is 3 points or ellipses, and we have 6 different cases there. Say again. Exactly. So here, variadic templates or so-called parameter pack. So we can have parameter pack, or we can have function parameter pack or template parameter pack, but that's essentially the syntax. Very related to that is also pack expansion. There are many different contexts in which we can do this pack expansion, and each context has some specifics to it, but essentially it's always a pack expansion. So I have only one category for that. Oh, yes. You disclose your age, actually. This way, a lot of young people do not know that this exists. Why it's useful even in C++? I mean, essentially, you can achieve the same functionality, but in arguably a better way with variadic templates. But still, this is used sometimes as an idiom for svinje, because it has lowest priority in overload resolution. Also, one interesting thing I've noticed, see that this is still okay. You don't need to have comma here, right? But for C++ 26, they are planning to deprecate this and say, no, it has to have comma here. So it's a bit, yeah. So interesting thing. So one more thing related to variadic templates, very closely related. Size off. Okay. So it gives us the number of elements in this parameter pack. Really? Yeah. Otherwise, it behaves like size off. So it never generates any instruction. It's always calculated in compile time. So 11. Yeah. Very early on. Oh, yeah. Of course, we can have variadic macros. So we covered all the cases. Here, regarding the comma, we have this interesting thing. So this is how we handle that in macros. But we are missing one more, and that's something that I personally use very rarely, and that's catch all for exceptions. And finally, the last category, 4 dots or double colon. It's just 3 to 4, and we already basically covered some cases. Try modules. No modules, of course. nested namespaces. That's one case. Sorry? Yes, scope resolution. That's how they name it in standards. So we have two subcases, qualified names as the typical thing, but slightly different cases related to something we already seen in the first group. Only in this first slide here, we had auto keywords, right? But now we see the actual type of these two variables, and that's pointer to member. Pointer to member. So you need to provide the object on which it will be called. No, because it's the first parameter. Technically, under the hood, it is like that, but on the surface, no.
Is the pointer to a member index?
Yes, yes, but you don't have the object in which it is, right? So you need to provide them. Yeah. Essentially, it's an offset. So you need to give it the base address. You provide the offset, and then you have the other arguments. Weird thing. I mean, I never used it, but it doesn't work. Yeah.
And it's actually used in projections where you can like pass like pointer to another function of the type, and in ranges so like a string comes to the algorithm should support it. But yeah, like if you want to do some operation with the like range of objects, but you want to call some member like variable or function, you can pass like address to member function variable. It's called a projection. The main use I have seen.
You passed the exam. Yes. Scope resolution covers a lot. That's why I didn't provide any examples, because there are a lot of different ones that I can give. And we have only one regular answer here. It's attribute namespace, which technically you also already saw in the category with just one column. But there is a bonus answer related to something that is to come, splicers in reflection. And you see this weird syntax, but technically it's two columns with something in between. Yeah, you're maybe right, but to be honest, I just copied this from this paper here without a lot of thinking about it. Just this yellow, that's my part. Thank you.
Thank you all for coming. And thanks everybody online. Thanks to all the speakers, and see you in 2025.